Okay, false positive, false negative. Okay, yeah, so this part is also important. Okay, so you will be given questions in the exam 3. Okay, so what is false positive, what is false negative, and how do we understand it? Okay, so we'll look at the textbook and really start to learn. Okay, so I'm going to ask the volunteer to read this 1, 2, 3 paragraphs plus this and and everything above. Okay, so everything above. Alright, so whose turn? I don't know. You did it, right? So Morgan, so I was a Morgan.
If you're tested for an allergy and you're told the results are positive, does that mean you have an allergy? If you take a pregnancy test and get a positive result, does that mean you're pregnant? In 1996, the American Medical Association approved a recommendation mandating HIV testing for pregnant women. Was this a good decision? Most people think a positive test for HIV means they have HIV. If you were told you tested positive for HIV, what is the actual chance you have HIV? To answer this question, let's look at all the possibilities, which include false positive and false negative test results. Suppose the accuracy rate for HIV testing is 99%. What does this mean? 99% of the time the test is accurate. 99% of people with HIV will get a positive test result, right? 99% of people without HIV will get a negative test result, right? 1% of the time the test is inaccurate. 1% of people with HIV will get a negative test result, which is wrong, and 1% of people without HIV will get a positive test result, which is wrong.
Okay, good, very good. Okay, so we have to understand about false positive and false negative. Okay, so let's talk about the first positive at first. Okay, what does false positive mean? So for example, I'm going to use an example about we're getting the HIV test. Okay, if your test turned out to be a positive result, doesn't mean that you're 100% getting the disease HIV. No. So that result turned out to be positive, but eventually you're not. That's called as a false positive, right? Because it's a false result about positive, but you're not having the HIV. Okay, so that kind of test result is called false positive. That means turned out to be positive, but you're not having the disease, right? This is called a false positive. And there are many false positive, okay, not just HIV, but for some other tests, okay, there are a lot of times, patient get a false positive. False positive does not mean that you have the disease or your test out, you really have something, okay? So you have to eventually do more tests and then rule out whether you're having the disease or not, okay? What does false negative mean? You're having the HIV, you're taking the test, but test out to be you're having negative results. This result is a false negative, means what? You have the disease, but test turns out to be red. You're having what? A negative results. So I think this is very dangerous, right? It's dangerous for some people that they don't notice that they're having something, but the test result turned out to be, oh, you're fine. Okay, so use the examples, we understand what is false positive, what is false negative, right? Okay, it says, okay, accurate if it is 99% correct for HIV means 99% of the time, okay, people with HIV will have positive result, and then people without HIV will have a negative results, okay, and blah blah, you can read this as well, okay. Alright, so let's put the accuracy rates into this table. Okay, so we know the this HIV test has an accuracy rate of 99%. So let's see, if a patient does has HIV, how much percent that the test will turn out to be positive? Accurate is 99%, right? You have a disease, 99% you will get a positive results, right? And there's 1% that you will have what? A negative results. Patient does not have HIV, 99% that test result is going to be what? Negative, right? That's a 99% accurate rate. And 1% that you're going to turn out to be have a positive test results. Okay, now let's look at this 2-1%. Okay, 2-1%. Which of these two 1%, they are the wrong results? Why they're wrong? Because when you have HIV, you should get a positive result, but you're getting a negative results. So this 1% is wrong. Is this 1% a false positive or false negative? Yes, this is a false negative because it turned out to be negative, but it's a wrong result. Okay. How about this 1%? You don't have HIV, but you test out to be positive. This is what? False positive. You guys, everybody? Okay, now let's go into look at all of these questions, okay, and then for the HIV question, okay, for the HIV question. Question 1, place the percentage above, okay, we did that, okay. Locate the label, the area in the table that represent false positive and false negative, we did that already, okay. Now, let's start from here, okay. In reality, a very small percentage of population has HIV. It is only about 0.5% of the U.S. population has HIV. What percent of the population does not have HIV? 0.5% has HIV. What is the percent that does not have HIV? 100% minus 0.5% give us what? 99.5% of the population does not have HIV. Okay, only small percent of people having HIV, right? All right, so our next several questions, okay? Suppose out of 100,000 people that are randomly tested for HIV, okay? So, question 3. 0.5% of the population has HIV. How many people out of 100,000 people would be expect to have HIV? How many? How to do the calculation? Out of the 100,000 population, 0.5% of them expected to have HIV. So how many? What is 0.5% in decimal number? 0.005, right? Times by what? Can you give me a result? 500 people. Okay, these 500 people are expecting to have HIV. Okay. Question 4. How many of those with HIV, these are people who does have HIV, will test positive? What is the accurate rate? 99%, right? You're having the disease, HIV. 99% you will get a positive results, right? Test positive results. So how many will get a positive results? Anyone know? 99% of the 500 will get positive results, right? What is this result here? 495. Okay. All right. So there is a table below. Okay. This table is so important. In order to do the homework assignment, to do your exam question, you have to know how to fill out the table. Okay. So far we haven't done all of the calculations, but we can fill out some blank areas already. Out of the 100,000 people, how many people are expecting to have HIV? How many? We did already, right? $500 people are expecting to have HIV. Put 500 here. We know 99% the test will turn out to be positive, right? So how many? 495, we did it already, right? So fill the 495 here. Okay. Of course, the next question 5 is how many of those with HIV will test negative. How many? Out of 500 people, yeah, 495 will test positive. How many will test negative? 5, right? So 500 minus 495, 5 people. So I'm going to put a 5 here. Will test negative. Okay? Question 6, 7, and 8 will help us to do this line. How many people out of the 100,000 will not be expect to have HIV? 0.5% is having HIV. What is the percent for not having HIV? We just did it from the previous page, right? 99.5% does not have HIV. So, 995 times by 100,000. $99,500. So 99,500 people are expecting to not have HIV, right? 99,500. And you see, the sum of 500 and 99,500 indeed gave us 100,000. How many people without HIV will have a positive results? These many of the people without HIV, 99% they will get negative result because they don't have the disease. 1% out of these people will have a positive results, right? So I would say 1%, which is 0.1, times by 99,500. And the next question will be what? 0.99, which is 99%. We will have a negative test results. What do you have here? 995, right? What do we have here? 98,500. Okay, so it is going to be 98,505, right? Everybody get the same answer? Now, how do we fill out this number in the table? This 995 should be put here or here. Without HIV have positive test result. Without HIV positive results, right? So 995 is here. And then 98,505 is here. Everybody? Okay, we're not 100% done for this table yet. There are 2 blank areas need us to do. This is for what? How many positive results in total? And this area, okay, this blank area is telling us how many negative results are there in total. So this will answer question 9 and 10, right? Total positive results and total negative results. So can you please tell me what do you have here and here? Here we should get what? 1490. And here add these two up, give us what? 98,510 people, right? So these are also answer question 9 and 10. How many positive test results? 1490. How many negative? 98,510. Right? You guys, everybody? Okay, question 11. How many false positives are there? Question 12. How many false negatives are there? So which numbers give us false positive? Which number give us false negative?
995 is false positive.
This is what? False positive. You don't have a disease but have a positive result. This is false positive. How about this number? False negative. Okay? So to answer the question number 11, answer is what? 995. Question 12, answer is what? 5. So far so good, everybody? Until now? Okay. Alright, now we are going to answer these questions 13 to 18. Okay? So let's look at question 13. What is the probability of having HIV if given a positive test results? Question for you. Is this probability question a conditional probability? Do you have E for given symptoms? It is. So what is the condition for the question? Given the positive results. So this is our condition. Okay? So given the positive results, what is the chance that people having HIV? Right? So from the table, given the positive results, right? So only 1490 people get positive results, right? What is the chance that the people that has HIV? 495, right? So we use what? 495 divided by what? 1490. Guys, do you see that? Okay, so say 495, 1490. What do you get? 495 divided by 1490. In decimal number, it is what? 30 something, right? 30% something, right? I think we get a 0.33, right? So it's about 33% that if you're having positive test result, there's only 33% of the chance that you really have the disease, right? So even if you get a positive test result, don't worry that much. Only 1/3 of the chance that you have the disease. Okay, so this is a question 13. Okay. Question 14, 15, 16. Okay, so for these 3 questions, I would like to give you a hint so you can finish them because I don't think they're hard. If you understand 13, they are the same thing. Okay. What is the probability of not having HIV if given the positive results, right? So condition is positive results, so you still put a 1490 on the bottom. And then not having HIV, what is the number? Okay, so divide and then give us the answer. Okay, 15. If given a negative results, okay, so put a number of negative results, and on the top, compute how many people are having HIV and also with negative results, right? That's on the top. Question 16, same thing. Negative results on the bottom, and then what's going to be on the top. Think about it. Okay? So question 17 and 18, they are not really math questions. Okay? So think about these 2 questions. Okay? Yeah, think about these 2 questions. So this is an HIV problem. Alright? So I would suggest that we do one more question. Fill out the table. Okay, fill out the table. So you can finish up these questions and check with the key. Okay, you're able to do them. They're not hard. Okay, and then we have another two problems. One is a drug testing question. The other one is this is also HIV, okay? So I will leave this HIV question for you to do it, okay? To do it in class today. And then let's do one more, okay? Let's do this one, okay? Drug testing, okay? Drug testing. All right, so think about this one, okay? Your exam question will be similar to this type, okay? Yeah, so they will blah, blah, tell you the question and give you the table. You should be able to fill out the table, and then from the table, answer some questions, okay? So let's try this question together, okay? All right, so I'm going to ask a volunteer to read this question for us. This paragraph and all of the four questions. Okay, whose turn? Andrew?
Suppose a company has 20,000 employees. The company decides to require drug tests for all employees. For the purpose of this example, suppose there are 500 employees actually using illegal drugs. The drug test has a 95% accuracy rate. Look at the following table and answer the question. If someone tests positive for drugs, what is the probability the person is not taking drugs? If someone tests negative for drugs, what is the probability the test is wrong if the person is taking drugs? If someone is taking drugs, what is likely the test result is positive? Which area is worse in the scenario? False positive, false negative?
Okay, very good. Okay, very good. So, assume this is the test question. Are we ready to do it? Okay. 20,000 employee. Okay. So, company decide to require drug test. Okay. All right. So, suppose there are 500 employee actually using the illegal drugs. So from this table, the 20,000, that's the total number of employees. Where should we put a 500? Here.
Total using drugs.
Yes. So there are 500 employees. They're using the illegal drugs. So these are the number for them. Now, how many employees are not using the illegal drugs? 500 they're using, and then there are this is a total number of employees. So how many are not using the drug? Use 20,000 minus 500, right? The difference will give us what? Employees who are not using the drug. Can you please tell me a number here?
19,500.
Yeah, 19,500. Okay, good. All right, so this test has a 95% accurate rate. Means what? If you are you're using the drug, 95% that you are going to get a positive test results, right? So how many will get a positive results? Out of the 500, 95% will test positive, right? So I would say 0.95 times by what? 500. You get a number? 0.95 times 500. I get a 475, right? So, how many people will get a negative result if they're using the drugs? Either, 25, right? Either you use 0.05 times by 500, get a, what? 25. Or use what? 500 minus 475. Either way, right? So 25. All right, these are the number of employees. They're not having drugs. 95% that they should get a what result? Positive or negative? Negative. So 0.95 times by 19,500. Right? I got a 18,525, right? And how many employees will have a positive results here?
975.
Okay, 975. How did you get it? Subtract the total by what? This, yeah, by this, okay. All right, now we have these two, okay? So in total, how many positive test results? 475 plus 975 give us what? 1450, right? 25 plus 18,525 give us what? 18,550. Are we on the same page, everybody? All right, now let's answer the questions. If someone tests positive for the drug, what is probability that person is not taking the drug? Is this conditional probability? Yes, it is. What is the condition? Positive test results, right? So, how many positive test results in total? 1450. Person's not taking the drug. Out of the 1450, not taking the drug, 975, right? So, you may get a result here. Okay, so please do this, finish that, okay? Question 2. If someone tests negative, okay, if negative results, what is the probability the test is wrong and the person is taking the drug? So how to set up this probability? How? Can anyone tell me what's going to be the denominator? 18,550, okay? On the top, it is going to be what? Person taking the drug, right? 25, right? 25. Get a number there. Question 3, if someone is taking the drugs, okay, yes, someone is taking the drugs, what is the likelihood the test result will be positive? You're taking the drug, what is the chance that the test result will be positive? Taking the drug, what? See? Taking the drug, this condition, right? So 500. What is the likelihood, or what is the probability, what is the chance test result will be positive? 475, right? So 475 out of 500, we should get what? 95%. And what is 95%? This is a given accuracy rate, right? So 95%. Question 4. Which error is worse in this scenario, false positive or false negative? I don't consider this is a really strict math question. I would say either your choice. I'll consider it's correct. Some people say false positive is more dangerous because, that scared people, okay? Some people say false negative is more dangerous because you have something, okay, but it turned out to be you're fine. Just like HIV, right? Well, this is not HIV, but this is a drug question. So I would say whatever you answer in question 4, you should be counted for correct. Okay? Yeah. All right, so this is a drug problem. So that's good for the drug problem, everybody? Okay, you have to know how to fill out the table similar to this, okay, in order to do your assignments, all right?